12 General End of Term Revision 1.1. Two light sources are said to be coherent. So, coherent is meant for expressing that they have the same frequency. So it means that not only they have the same frequency, and they also maintain the same phase difference. So it is option B. Explain how light can interfere either constructively or destructively. For example, constructively, for a constructive, to have a constructive, I must have a crest with crest. And also, I must have a trough with a trough. In these two cases, I will have the amplitude building up. In case I have a destructive, perfectly destructive, I will have a crest plus a trough. So the question is, when light waves interfere constructively, what happens to the amplitude of the resultant light? Basically, it increases. Question 6. Destructive interference happens when what of a wave meets what of another wave. So we agreed that for a destructive, it must be a crest and a trough. So it's option B. 1.1.13. Explain that constructive interference occurs at locations xm on either side of the central bright band. So basically this is the pattern. Here we have order 0, first order, second order, and third order. Which fringe is the third order? So the third order is E. Okay. Later we're gonna try to analyze the changes that occur to the fringe pattern depending on the wavelength, on the length, and on the distance between the slits. So basically, when the wavelength increases, this is directly proportional with x. Let's see. So what happens to the spacing? This means what happens to x between the fringes in a two-slit interference pattern if the following changes are made, keeping other variables constant. If the slit separation is increased, so by increasing the denominator, basically x will decrease. So x decreases because they have inverse relationship. So x will decrease when d will increase. We can say either x decreases, or we can say that the fringes, they get closer, narrower. B, color light is switched from red to blue. So the lambda of red is bigger than the lambda of blue. So by switching from red to blue, this means that the wavelength I have decreased. And when I decrease now, by keeping L and D constant and decreasing the wavelength, so x and lambda, they have a direct relationship. I can say here, lambda decreased, so the spaces also decreases. This means that the fringes, they get narrower, closer to each other, anything that expresses the same idea. Later, the monochromatic light is replaced by white light. So in this case, I will have instead of having fringes that are evenly spaced like this and monochromatic, this means it is the same color. Instead, I will have the central one is white, and on the both sides I will have a rainbow. So I will have here like a rainbow on, so I will have the central fringe white, followed by a sequence of rainbows. Finally, D, if the width of the two slits increased. Now I know that X has to do with lambda, the wavelength, the separation between the the slits and the screen, this distance from the slit to the screen, and the distance between the slits. But I have nothing to do with the width of the two slits. So only like more light will pass. So this means that only the intensity, that's because more light will come in, the intensity of light emitted by the slits increases. The intensity of light increases, but in terms of the distance between, in terms of X, it stays the same. So that's only brighter fringes. But X stays the same, not narrower nor wider. 1.1. Let's have some additional practices. Sunlight is an example of incoherent light because it is not having the same frequency. What's the meaning of monochromatic? They have a single wavelength, or they have the same color. What characterizes the dark fringes? It is actually due to a destructive interference. A bright is for a constructive interference. Later, two beams of coherent light are shining on the same piece of white paper with respect to the crest and troughs of such wave. Darkness will occur on the paper where? So where darkness will happen, so basically it is between a crest and a trough. Now, with some direct application, a double slit is illuminated with monochromatic light. So that's the wavelength. I don't forget to convert. So M equals to 1. Fringes are separated by 1.8. That's X. And not to forget to, so that's X. Okay, it is located 3.5 meters, that's L. Now, what is the separation between the slits? Now, I have X equals to lambda L over D. Or I can write the equation that I have here. Lambda equals to x d over L. So lambda is 6.11 times 10 to the power of negative 2 times 10 to the power of negative 9 equals to the spaces between the fringes is 1.8, 10 to the power of negative 2. I don't know the space between the slits. It is 3.5 meters away, so it will give me that D equals to 1.2, 10 to the power of negative 4. The unit is in meters. Question 19. Two slits separated by, so that's D, are illuminated by light of wavelength this much wavelength. If the screen is 6 meters from the slit, that's L, what is the distance between M0 and M1? So I need to find X, as is in question. So it is M lambda L over D, which is 1 times 625, 10 to the power of negative 9. L, 6 divided by D, 2, 10 to the power negative 5. So it will be around the answer is 18.8 centimeters. Question 20. In a double slit also experiment, the slits are this much apart on a screen that is placed 0.75 meters away. So this means this is L. The first order, M equals to 1. Order bright is found to be 1.35 from the central. So this is X. What is the wavelength? I need to figure out the wavelength. So wavelength is XD over L, 1.35, 10 to the power of negative 2. D is 0.025 millimeters, so 10 to the power of negative 3 over the distance is 0.75. This will give me X, or sorry, lambda equals to 4.5 times 10 to the power 7 meters, which is this one. More with practices in a Young double slit. What happens to the intensity of the bright bands as you go further from the central band? Basically, it gets dimmer and dimmer. It decreases. So the intensity certainly decreases. Dimmer. In a Young double slit experiment, green light is incident on two slits. The interference pattern is observed on a screen. Which one of the following changes caused by fringes to be more closely spaced? So, more closely spaced. So I was using a green. I should be using, let's say here, X equals to lambda L over D. In order to have a lesser X, this means like closely spaced, yani X is less. So this means I must use a smaller wavelength. So I can go, let's say, to blue. So use blue light instead of a green light. Not use red. When you use red, this means that the lambda is bigger. No, blue has a smaller wavelength than, so basically lambda of green is bigger than lambda of blue. Monochromatic coherent light shines through a pair of slits if the distance between these slits is decreased. So here we go, distance is decreased. Which of the following statements are true regarding the resultant interference? So basically the spaces between the fringes will be bigger. So distance between maxima stays the same, that's not correct. Distance between maxima decreases, not correct. The distance between minima increases and the distance between maxima increases. Minima means bright fringes, maxima we mean here by the dark fringes, so they just get wider. The figure below shows the viewing screen in a double slit experiment with monochromatic light. Which of the following can be true about the fringe if the wavelength of the light is decreased? So again and again, x is proportional to lambda L over D. So when the wavelength is less, so basically also the spaces x between the fringes decreases. Fringe spacing decreases, yes, correct. Fringes increases, the color of the fringe, yes, it changes. So here we are changing the color. So 1 and 3 are correct. For bright bands, it is a constructive interference, and here it is a destructive interference. Question 9. Light of wavelength, I have the wavelength, falls on a double slit. Use the values from the figure. I can see that this is L, this is X, I don't know, D. So I replace each by its value. So that's 4 10 to the power of -2. Lambda is 542 nanometer. L 1.2 divided by D. So D equals to 1.6 times 10 to the power of -5 meters. Following question. Also in a Young double slit experiment, the screen is separated from a double slit by L. The distance between two slits D, the second order m equals to 2 is measured to be 4 centimeters from the center line. So that's x. Determine the wavelength. So wavelength is x, 4 10 to the power of -2. D 0.03 10 to the power of -3. That's because of the conversions. M equals to 2 and L 1.2. Lambda is 5 10 to the power of -7 meters. Thank you.